Hi everyone, welcome. Hopefully you're in the right place. This is the Operator Framework Workshop. We are here this is 1 hour, so we're going to be going at a hour and a half, that's right, thank you. An hour and a half, so we're going to be going at a very, very quick pace. Where you're going to learn all about what operators are, what the Operator Framework is, how you can use it. And for those of you that use Kubernetes every day, guess what? You might learn a few things that are going on behind the scenes that you never knew about before. So let's go ahead and do some introductions. My name is Matt Dorn. I'm with Red Hat. I was previously with CoreOS and part of the CoreOS acquisition. Before that, I used to work a lot in the OpenStack world. And I'm happy to be here. Lily?
Yeah, sure.
Yeah.
Hi, I used to work at Operator SDK. I moved on to monitoring. I'm just here to help out, ask any questions, answer anything, really.
Sure.
Yeah, I'm an engineer at Red Hat, basically.
Thank you.
Hey, I'm Michael Hrivnak. I've been at Red Hat for almost 8 years. In the Kubernetes space for several of those years, worked on the Operator SDK, and before that, a thing called the Ansible Service Broker, which is part of the whole service catalog ecosystem in Kubernetes, and have just generally been in the space of automating workloads on Kubernetes for a while. Most recently, I've been involved in bare metal support, so running Kubernetes on bare metal, which is pretty cool. Turns out you need a lot of controllers to make that happen too, and we're using this same technology to do all of that. So very happy to be here, and I'm going to talk with you about building Ansible-based operators in a little bit in the second half of this talk.
Great, and we're going to be going very, very quick, so I do ask that, if you have any questions, we are going to have a Q&A immediately after, but please come talk to us. We have Red Hat people here in the front. These people also deal with Red Hat certifications of your operators and can talk to you about that, and we're here to help you if you need anything. So please don't leave with your questions unanswered. We're here to help you, okay? So let's just get an idea of what's going on inside the room here. How many people here use Kubernetes and OpenShift regularly? Well, we are at KubeCon, so I expect there's going to be a lot of hands up in the air. Okay, yeah, most of you. Okay, how about this? How many people here develop in Golang regularly? Okay, great. Okay, that's like, what was that, like a quarter maybe of the people? Yeah, about a quarter. How about this one? Use Ansible regularly. Okay, do we have more Ansible people in here or more Golang people, do you think? Based off? About the same, okay, all right. And anyone here attempted to build or actually did build, maybe you didn't get frustrated and gave up, build a custom Kubernetes controller from scratch? Custom Kubernetes, okay, a few people in here, okay. So for those of you who have been hearing all about this controller stuff and you're not really sure how the internals work, this is a good workshop for you to be in. Has anyone here tried Operator SDK, Ansible Operator, or the Helm app operator yet? 1, 2, 3, 4, 5, 6. Okay, cool. Few people. So hopefully, today you are going to use it and get a feel for how it works. Okay, so our goal here is to help you succeed with our tools. So in this entry-level session, we're going to be talking about the operator framework. Okay, what it is, why it exists, all that good stuff. Support channels, because you're going to need it once you start diving deeply into operators. Google Groups we have set up for you. We also have Kubernetes Slack. This is the official Kubernetes Slack. If you go to that channel, Kubernetes Operators, we're always in there hanging out, and we can help you, okay? And the OpenShift Commons Operator Framework. This is a group that gets together every third Tuesday of the month at 9 a.m. Pacific to talk about all things operators. Maybe you're working on an operator, and you want to share it with the community and see what they think about it. That's where you do that. It's a live meeting, okay? So let's start out with what an operator is. But before we do that, let's make sure, we were talking right here, let's make sure the lab environments work, okay? Let's make sure the lab environments work. So what we're going to do is, I'm going to show you what URL to go to here. Let's make sure this stuff works. Go to learn.openshift.com/training. Okay, so for those of you who just showed up, the reality here is that you are using a dedicated instance, a dedicated OpenShift instance running on EC2, on Amazon EC2. It's embedded into a program, into a web app called Katacoda. which if you haven't heard of Katacoda, you're going to experience it now. It's awesome. It was just acquired by O'Reilly. When was it? Thank you. No, it's training here. It was just acquired by O'Reilly a couple days ago. So congratulations to Katacoda for that. I'm going to give this a second to see if it comes up. Again, the link is, let's see, learn.openshift.com/training. Learn.openshift.com/training. So what we're going to do here is a little smoke test. All right, go ahead and click on Start Training here. We're going to need feedback from you all to know if this stuff works. Okay? Click on the first scenario here. Start Kubernetes API Fundamentals. Click on Start Scenario. Okay? It might take a while. Then you're going to click Start here. It says connecting because it's provisioning the instance. It's spinning up on demand. How many people currently on their screen, it says connecting? You're waiting for it to connect. How many people, okay, a few people over here. How many people have it's up and running? How many people, these people that didn't say anything, what's going on? Okay, I didn't realize that was, okay, blank screen, okay. Thank you. Okay, so give it some time, okay, because we provisioned this thing for 500, it's supposed to be able to handle a capacity of about 500 people in here right now. We'll see what happens.
They're showing up slowly.
Okay, okay, cool. Let's go ahead and let that run while I go through the introduction, okay? For those of you who have yours up and running, feel free. You don't want to hear me talk, play around with this. This is pretty cool. It's just a little smoke test. We're creating a pod, right? I'm sure we all know what a pod is in here, with a couple containers inside. So have fun and play around with it. It is an actual instance. Feel free to blow it up if you want, okay? All right, let's go to the intro here. What's an operator? Now look, maybe you were probably here like, oh yeah, why are you going through what an operator is? Look, the reality is it's totally possible that you all have been walking around this conference, everyone's talking about operators, you don't even know what they are, right? Which, I don't blame you. It's like, it's kind of hard. People throw in all these terms, what are we talking about here? It's kind of hard to understand what they are. The actual definition, if you were to go to look it up, would say, an operator represents human operational knowledge and software to reliably manage an application, right? But what does that actually mean? What are we talking about there? Let's go back a few years. So a few years ago, back in November of 2016, Brandon Phillips, the CTO of CoreOS. If you don't know CoreOS, a little startup right in San Francisco that specialized in something called Container Linux, an operating system that's sole goal in life was just to run containers, right? Talks about this on their blog, this idea of this new piece of software called operators, right? And it says an operator builds upon the basic Kubernetes resource, controller, and application-specific knowledge concept. Those three things. So an operator is nothing more than a nickname that fits this criteria. It's got to have these three things to be an operator. Again, operator is just a nickname people throw around. Is it an operator? Well, does it have these three things? What three things? Resource, controller, or knowledge. Okay? What's going on here? Like, it has to have these three things. But what are these? What's a resource in Kubernetes? Well, we should know what a resource is in Kubernetes, right? A pod. We know a pod can have one container, multiple containers, right? We have a config map for application data there, key values. Route, for those of you who don't know what a route is, that's kind of like an OpenShift term, but it's the same thing as ingress, right? You need a way to get people access from the outside world, access to your application. That's what a route provides, okay? And two, we have controllers. Controllers. What are controllers in Kubernetes? I know you all know what controllers are, right? The replica set. The replica set, right? When you specify the number of pods that you want running, and it ensures that that number of pods are always running. That's what's really cool about replica sets. We're going to learn about why studying the replica set is a great way to learn about operators. If you study the replica set, it really helps you understand what an operator does, right? What else is daemon set? Who knows what a daemon set is in here? Right? Daemon set. They run on every node in the environment, right? And typically they have host level access. They're pretty cool. I like daemon sets. And then deployments. Before deployments came around, we had to do client-side rollouts. If we wanted to roll out a new version of our application, right, we had to actually go and manually client-side send an API call to create a replica set number 2 and version number 2 and do that. Deployments are great. They manage our replica sets for us. They do the server-side rollouts for us. You can determine the availability or specify the availability. They're cool. So what's domain or application-specific knowledge? What are we talking about here? We're talking about knowledge specific to your application. Knowledge specific to your application that only you know because you know your application inside and out. You know all the knobs you have to turn. You know about being woken up in the middle of the night and you have to maybe SSH into the server and then modify something in this application. You know all its quirks, all its things. We're talking about knowing how to install it, how to scale it properly. What do I mean by scaling properly? As if it's a stateful application, not just statelessly, like a replica set, just having one pod here, one pod here, one pod here, right? Scaling it properly. Self-heal. Self-heal. So aware when something's going wrong. Cleaning up, updating, backup, restore, etc. Okay? So we're going to dive more into this, still high level. I know you all know what this is. You probably look it up all the time. When you want to create something in Kubernetes, I'm sure you just go and you Google, deployment. And then who here uses the explain command? Who here knows the explain command? If you don't know the explain command, you should be using that every day, right? The explain command actually, kubectl explain, deployment, kubectl explain, replica set. That thing talks to the API, right, and gets you back information on how you can actually fill your declaration, right, out. So in this manifest we have here, the way to think about this, when you look at this in the future, think about it as 4 different parts. You're looking at 4 different parts here. The first part is the GVK, or group version kind. We also call that the type meta. That's the group, version, and kind here. We also have the metadata or object meta. You know about this, right? You can put a namespace in there. If you're not scoped to a specific namespace when you're using kubectl, or if you are scoped to a specific namespace when using kubectl, you don't have to put namespace in there. Annotations go in there. The owner references end up in there, which we'll talk about later. Labels. We could put a lot of stuff in there. Okay. So spec. What about spec? So in our spec here, this is our declaration. This is what we want, right? So what we're actually doing is we're saying, I want to make this replica set that has 5 replicas, right? And then we can specify 1 container or multiple containers. This is your declaration. This is what you are requesting, right? This is your declaration, what you want. Now, the 4th section here, status, it seems like, a lot of people that get new to Kubernetes are kind of like, well, I assume when we talk about operators as kind of comparing the actual state of the cluster to the desired state, this being the desired state, that this is the actual state. A lot of people think that. But no, the status is only written by your controller, and it's a way to provide information to your users. It can also, if you're creating maybe a more advanced operator, be used as a way to store previous old state. So if you want to check and only do something, if this is in ready status, your operator can actually look at that and decide whether or not to proceed if that's in a certain status, right? But my point about talking about this is that this is something that a user does not fill out, that a human does not fill out. Your controller does it to provide information to you, the human, or perhaps other operators running in your cluster. Operators take advantage of custom resource definitions. Okay, so those of you who have used these before, you know that these things are incredible, right? Because they allow you to extend the API via the API, okay? So you don't have to actually go and grab the Kubernetes code and then, like, for example, if you wanted to add a new resource, like let's say you wanted to add a new resource called KubeCon, so you could do like kubectl get KubeCon or something, right? Or have an endpoint. If you're visualizing the API endpoint, right? You're visualizing like v1 beta 1 slash like namespaces slash whatever slash KubeCon, like the actual resource. You don't have to actually bring down the code and make that change. You send an API call to modify and create that new resource on the API. That's pretty powerful command, right? Because I mean, it literally impacts the entire cluster and everybody using the entire cluster. So here we have an example custom resource, just so you can see what one looks like. This one is called Kind Grafana. What do you think this does? If you had a guess, if you had to take a wild guess, what does this probably do if you were to apply this? Probably creates a Grafana instance or something, right? This is just an example of showing you this. You can see, though, there's some configuration parameters in here, right? So it's kind of like rather than using like a configuration file or a config map and having to mount that config map as like a volume mount, right, into like a deployment or whatever, like we're just specifying what we want as a declaration in the spec section here, right? And the cool thing about creating CRDs or a custom resource is as an author, I can actually design this. I can design what users can put into here, right? Which is really, really neat. So let's go ahead and just show you an example of extending the Kubernetes API by creating our very own object or resource via CRDs. So for those of you who have done this before, just go play on the lab environment and look around. And I'm probably boring you. You've done this. But if you're not really familiar with CRDs and you've been in the conference for the past few days and you're like, what is this thing, CRD thing anyways? This is basically what it is. Really straightforward. Creating the CRD. So what we do here is we create the CRD first, the custom resource definition. And literally, the kind is custom resource definition. This is the first step to creating a CRD. You can see that this right here is the customized piece, MySQLs. I'm just making that up. I want to create an operator that, let's say, creates MySQL. Easier said than done, as we're going to see. But point is I'm creating my custom name here and my custom group here and here. What's the group? The group is nothing more than a way to disambiguate different kinds that may have, or let's imagine this, different companies all come out with MySQL operators, right? And they probably all create the same kind MySQL, right? Well, how do you tell the difference? One's going to be company A, one's going to be company B, right? So that'd be company A, company B. And then here, we're saying here the version. Well, this one starts with V1, but I should probably fix this slide, because what do we want to start with usually? We want to start with V1 alpha 1. Right? That's what we want to start with, usually. So I should probably fix that. So don't look at that right now. OK. Scope namespace. Scope namespace. This is saying, after I create this custom resource definition, which, by the way, let me ask you a question. What do you think that this object here is going to be scoped to? First of all, do you think you need privileges to do this? Would you think you need pretty wide privileges to create something like this? You're modifying the Kubernetes API. Think about that. Yes, you need some pretty cluster-wide privileges to do this, right? You're literally modifying the API. But then this block here says scope namespace. Why are we talking about scope namespace, right? Namespaces are how we do multi-tenancy in Kubernetes. Because after we create this, and we want to create the kind MySQL object, right? We're going to want that scoped to a namespace. So if we have example MySQL, that's going to exist in namespace 1. But if I want to create another example MySQL, that's the name literally, we know that we can't have multiple objects with the same name, right? So we're going to put that into another namespace. So that means it's going to be scoped to the namespace. What do you think the opposite option of this is? If you had a guess. Cluster-wide. Exactly right. Very good. Yep. So this is just a couple ways to refer to it and some aliases that we can refer to, which is very awesome. I can say kubectl get ms. And it understands what I'm talking about. How does it do that? The client does discovery, right? Right when you type the word in, it's going to scan the API for the alias or nickname. And it puts that in the dot, what's the directory? Any of you all know. Is it a dot cache or a dot, yeah. Is it kubectl, is it a dot cache directory that it puts it in? I think it's a dot cache directory or something, right? Yeah.
So we're aware that the environments are having a connection error right now. I've reported it to Ben. And we're going to try to get that fixed as we're going. So hang tight, as they say in this environment with that. Hopefully we'll get that back up.
No, thank you. I appreciate it. Thanks. And then you create the CRD. After we verify the creation of the CRD, we then go in and we say OC get CRD. And how do we know it's there? Is it there? Yes, it's there. We say OC. Oh, you're probably wondering what's OC. OK. So OC is the OpenShift client, right? Maybe I'm a little biased. We're really in OpenShift. It's just like kubectl. What do these things do behind the scenes? They're just sending API calls, right? They're just talking to the Kubernetes API. So OC is just like kubectl. OC just has some extra open shifty stuff added to it, but it pretty much acts like kubectl. Same thing. You can use both interchangeably. Okay, they work really great. So we're saying kubectl get CRD, and it comes back and goes, that's your CRD. Let's now actually verify our new MySQL resource and object. So what we're going to do now is we have the CRD created. Check this out. Now I can actually go up here and say OC or kubectl get MySQL. I could actually say get MySQL. And what happens is it comes back and says no resources found. Now everybody thinks at this point when they see this, they're like, oh, it didn't work. But this is a good thing. This means that behind the scenes, kubectl or OC talked out to the API and actually found an endpoint. When I say endpoint, it found a namespaces /v1 alpha1 / whatever, right? It found /MySQL. It found it, but guess what? There were no objects in there yet. We haven't created one yet, so let's go ahead and create an object. So when we create this object, it's going to look like this. db.example.com /v1. It has MySQL in it. It says name WordPress, user, password. You may be thinking, like, where did you get this stuff from? How did you know to put this stuff in there? Well, let's just say that you can actually customize your custom resource definition with the same information you get back when you use OC or kubectl explain. So for those of you who use the explain command, you can, inside your CRD, you can actually program or customize what comes back. So I could actually have it say kubectl explain MySQL, and it will tell me, okay, you can put user here, you can put password here, you can put, foo here or whatever. It will give you, and you can program it to give you instructions. But the reality is that this right here, this is not really doing much yet. We're just adding this to the API. That's it. You can probably guess what we're doing here. We're trying to create a WordPress database, right? Just as an example. So we go ahead and create that object. After we create that object, we say kubectl get MySQL. It comes back and says WordPress. If I want to actually look at the object, my object is actually in here. It looks good. It's persisted on the API, thus persisted where? If I see it, where is it sitting? Where's the source? That's exactly right. It's sitting in etcd, right? The greatest key value store, okay? So that doesn't really do much for me when it comes to an operator. It gets me done with number one. What's the number one requirement for an operator? I need a custom resource definition, right? Yeah, that's right. So it gets me that. That's good. But a custom resource, it needs a controller to act upon its presence. So without a controller, you just have this thing on the API, and that's it. And that's not going to get you much, right? So what do controllers do? Controllers literally sit in the cluster. They sit in the cluster, and they just watch the API. Now, how they watch the API, we usually talk about when we run a version of this course over a couple of days. We get into the hardcore specifics, sort of like informers, shared informers, the watch, all that good stuff that those of you who use Client Go know and love. I know you all know what I'm talking about, but for those of you who don't know, just know it watches the API, okay? It just watches the API for the current state of the cluster. Then, after it watches the current state of the cluster, it analyzes, okay? It compares the current state of the cluster, like how many pods are running and how many config maps, and whatever I want to look for as the current state, to the desired state. Where does the desired state live? You tell me. Yeah, that's exactly right. It's in the custom resource. And which section? The spec section. That's your declaration, right? That's what you want. That's what you want in the declaration. So it compares what is. Do I have any MySQL things running? How many pods? Whatever. Do I have any deployments? Do I have any, PVs? Whatever. To what I want in my spec. And if I don't have what's desired, what does the controller do? It acts. Right? It performs all the actions necessary to make a current state meet the desired state. That's what it does. And that loop runs whenever it receives an event. And guess what? For those who use Kubernetes and you've never used it internally, which is totally fine. Maybe that's not your scope of your what you do day to day. It's totally possible to use Kubernetes every day and not get into the internals. It's just not part of the scope of what you do day to day. But this thing right here, when we talk about events, we're not talking about kubectl get events. That's not what we're talking about. We're not talking about kubectl get events. We're talking about events that you get when you watch the API. You get an add event when that CR is created. You get a update event when the update is modified. I'm sorry, when the CR is modified. How do you modify a CR? You could run kubectl replace, right, on the command line. How else? Some of you probably use kubectl edit, right? You do kubectl edit, and you go in there, and you like using your editor of choice and editing it that way. Maybe you do it that way. That's an update. And then if you delete it. So this thing only happens, this trigger only happens for those 3 different events: add, update, and delete, okay? So it's not like your regular kubectl get events. Totally different type of event. This is an internal event here. Replica sets in action. Remember I told you that understanding how replica sets work can really help you in understanding operators? There's our replica set, which notice how it has a selector. It's saying I'm looking for app equals my first app. We have a pod here, app equals my first app. That's how it knows to pay attention to this pod because it has the same label. We have replica set to 1. What happens here? We change replicas to 3, and it's smart enough to know to spin up 2 more, okay? Pretty straightforward. That's our primary resource. These are our secondary resources. That's just a nickname that we use to refer to something like this. So imagine the replica set as sort of like the custom resource. Think of it like that. It's kind of like the custom resource, right? And these are the kind of the children or secondary resources that are being controlled by that thing, by that replica set. Now, owner references are things that you may not know. You may not know what an owner reference is, right? You may have no idea what owner reference is, but you use them all the time if you're spinning up deployments. You may have never just maybe you just didn't really notice. Owner references help us with garbage collection, right? Because you think about it. If you're creating these things called deployments, or if you're creating a custom resource and it's creating things, like you don't want to, when you delete the custom resource or you delete the deployment or whatever, or you delete the replica set in this case, you don't want your pods hanging out, right? After the thing's been deleted. You want those to go away too. That's what owner references do. Okay? So if we have a replica set, we spin up a replica set, and we have pods here, because we want 3 replicas, they all have an owner reference. Now, what the owner reference does, for those of you who don't know, if the owner goes away, so in this case, the owner here is this replica set. If the owner goes away and gets destroyed and never comes back, well, I just say, if it goes away, guess what happens to the orphan here? It goes away, right? It's kind of sad, right? So pod has a parent goes away, it's gone. Guess what? Child is gone. That's how they work. Who controls that logic? The garbage collector that runs and is embedded into the controller manager in Kubernetes. So this is embedded. You get this for free in Kubernetes. It's not an operator thing, okay? It's not an operator thing. Very important when you're creating an operator, understanding how owner references work, because you don't want to have people, you don't want to leave a mess, right? You don't want to leave a mess when someone deletes your custom resource. Okay, so how does the replica set control loop work? It gets triggered. This is kind of like we showed you before. It finds pods matching the label selector. We compare the matched versus desired pod count, right? So think about this. If there's too few pods, when we're comparing the match versus desired, right, we're going to create some additional pods. We'll have some logic in there. If there's too many, what are we going to do? Delete them, right? We're going to delete them, get rid of them, delete that, and then guess what? This thing gets triggered anytime there's an event, okay? And then you can actually see these in action here. It's getting a little more detailed. You have a Kube API. You have a Replica Set Controller. The Replica Set Controller watches for replica sets. So it sees events based off replica sets. And you have pods. It also watches for pods, but not just any old pods. It watches for pods that are owned by the replica set. And check this out. Create a replica set. There's an event that gets triggered. We then do a list against the API for the actual state. Turns out that the actual state is 0. It's less than the number of desired replicas here. So what do? We then create one pod. Guess what? We get an event based off the creation of that one pod. We then list again, get the actual state. Now we have 1. All right? You all seeing what's going on here? Right? And this is the triggering here. Every time you see these events. And I think it's important for you to understand that these events, your controller doesn't actually know that they're add events. It just knows that they're you get an add event, sure, but your controller doesn't care if it's an add event, doesn't care if it's an update event. It's not like you have a bunch of if statements in there in your logic, right? It's not like that. We're going to look at the logic coming up here. It's going to be very fast because we don't have a lot of time. Oh, now we're happy. Why are we happy? Because now 3 is desired is equal to what? Actual. And that's good. And then guess what? When that happens, your controller stops. every time you see an event, that is the controller, what we call, there's a nickname for it, reconciling. This is the control, on the right is the controller. On the right is the controller, right? So just take, yeah. You could.
So he's asking if you want 3 pods, you might code it to loop 3 times or something along those lines.
Or just 3 at one burst.
Yeah, 3 in one burst, yeah. Oh, 3 all in one go. Is that it?
Yeah.
Yeah. And sometimes you do want to do that, but sometimes it's sufficient and even desirable to just take one step in the direction of the desired state instead of going all the way to the desired state. And it really depends on what exactly you're deploying and why. In the case of pods, probably it would be fine to go ahead and deploy all of them, like figure out the entire difference between desired and actual and just do it all in one shot. But in other cases, it's advantageous to not. You're going to come around for another reconcile loop immediately anyway, so there's really no harm, and in some ways it's a better pattern to do it incrementally. It's easier to test and that sort of stuff.
Yeah, and the performance is obviously it's very fast, right? When you do it this way as well. Okay. So, and look what happens when we delete a pod. We get a delete event too, right? So there goes our delete event, and then we're going to have to get that actual state again, which says there's 2. So obviously, you have to go and create a new pod. We get a pod event. And then we're happy, okay? So going back to the MySQL example, check it out. So remember, we didn't create a MySQL controller yet. We were just showing you how a replica set works. But notice how the CR is sitting on the API here by itself. Nothing is happening in our cluster because we don't have a controller. So what we have to do is we actually have to go and, it's very quiet, we have to go and deploy a controller in our cluster, right? And notice how we have these controllers. Now this is actually, I got to change the slide because even though we want to have multiple controllers running, guess what? Only one is allowed to actually contact the API and act on that object. You don't want these controllers stepping on each other's toes here, right? So we have in place leader election. So one controller will be able to actually watch the API here. So don't be confused by this. I need to fix the slide. And that's going to thus spin up our MySQL pod. But obviously, I'm missing a lot of stuff here. We probably want to have multiple MySQL pods. We probably want to have these deployed as a stateful set. We probably want to have multiple PVs deployed. Didn't have time to put all those graphics on there. But here's the reality. It's actually more complicated than that. I mean, you're free to use any of the primitives or any of the artifacts that you get with Kubernetes to actually go and deploy this MySQL instance, however you want to do it, right? You're free to do that. But it's really a lot more complicated than just creating something or reading it and updating or deleting, okay? Think about, anyone here a MySQL admin? Think about all the things that you have to do when you manage MySQL, right? Like all the tasks. These are the things that you need to think about when you build your operator. These are the things that you're going to codify and put into your operator. Now, how you put those things in there, you can use the Go. You can use Go to do it. And if you're comfortable with Go, and that's where you feel comfortable, you can do that. But think about this. You can use Ansible to create an operator, too, with the Operator SDK. And you're probably thinking to yourself, I can use Ansible to create a MySQL operator? Man, you probably want to be pulling down those MySQL Ansible modules, right? Maybe those of you who use Ansible, right? So we'll talk more about that when we get to the Ansible piece as well. But point is that this is the human operational knowledge we're talking about. How you codify that and how you put this in to your operator. And again, think about more of an app. Think about an app that you know and love. This is kind of general, MySQL. The ins and outs of that app, that's what you're going to put into your operator. How you do that, we're going to talk about coming up. So to recap, custom resource definitions plus custom controller plus your knowledge equals operators. Why do they matter? Here's the whole idea. We're trying to build an as-a-service experience, right? What do we mean by that? You go to AWS, you go to GCP, you go to Azure. You want to go ahead and provision a database or something. It's very easy. You just fill out some fields, click some radio buttons. If you use the UI, you're probably using Terraform or something, to actually programmatically interact with that infrastructure. But you get what I'm saying. It's like a very easy experience. You build an ecosystem of software on Kubernetes that can be as easy and safe and reliable to use as a cloud service. Low touch, remotely managed, one-click updates, right? Giving you that really nice, low touch experience. An example of an operator on the dashboard looks something like this. When I say dashboard, you're probably thinking, what dashboard? What do you mean? I just mean from the UI, if you were going to deploy an operator, like this is what we're going for, like making it look like just clicking a button and go and enable it. Here's the etcd operator. That's for your apps running on Kubernetes, Prometheus, and for monitoring, and Volt for secret storage. It's really easy to deploy an operator in a Kubernetes environment. How do you create your own operator? Right before the Operator SDK. It's really, for those of you who've created an operator, you know it can be a little complicated, right? It's not just as simple as creating some resources and then defining a controller with some pseudo code that looks like this, right? It's actually a lot more complicated. They require many building blocks of boilerplate code. You have to research and download tools to interact with the API. First of all, you start with the client libraries. For those of you who know, there's not a whole lot of docs on these client libraries, right? Maybe some of you who are, maybe you may not be, it doesn't matter, you just read the code anyway. But, Go, Python, Java, .NET, what is this stuff for? It's for programmatically working in the language that you're most comfortable in to interact with API, interact with Kubernetes, right? Specifically the Kubernetes API. Yep. Okay, cool, thanks. Wow, I didn't even realize that. Okay. I was thinking, knowledge of informers, shared informers, or object cache and event handling. Why do we care about object cache and event handling? Think about this. What do controllers do? They watch the API. You have a whole bunch of controllers running in the cluster, right? Tons of controllers running in the cluster. They're always running in the cluster. They're watching the API. What does that mean for the API? That poor API just getting beaten, right? So how do we make it more efficient? The controller has, caching. We have a work queue that we work off of. Communicating desired state. You have to build that if you do this from scratch. It's really annoying. This is an example. We're just using client code directly, just showing you what a sample project would look like. And we need an easier way to create operators, an easier way to manage operators. That's where the operator framework comes in. It consists of Operator SDK, allows you to create an operator with Go, Ansible, or Helm. You can convert all your existing Helm charts to an operator if you want to, okay? We're not competing with Helm. Helm is awesome, but if for some reason you want to create an operator and put it in the operator hub, you can do that with, or put it in your operator hub, which is nothing more than like an app store. You can create your own if you want, kind of your own registry of operators. Helm helps you. The Helm helps you do that with the Helm side of the Operator SDK. This is the full life cycle, going through 5 stages of maturity. And everywhere up to autopilot, which is fully running on its own, auto-scaling, responding to custom metrics. For those of you who are devs, you're developing operators, Prometheus metrics, definitely learn how to instrument your app. That's really important using the Prometheus libraries because autopilot responds based off thresholds of those custom metrics, okay? That's exactly right. You can choose either one. You can choose Helm, you can choose Ansible, or you can choose Go. Yeah, that's exactly right. That's what it's saying here. Maybe someone, if you all work on Helm, or if anyone here works in the Helm community, we can talk about this, but that's what this is suggesting, yeah. And then OLM. OLM handles the installation, the upgrade, the whole dependency management with operators. How do you install them? How do you upgrade them? All that good stuff. This is actually giving you that App Store-like experience. Think about this. When it comes time as an operator author for you to roll out a new version of your operator to your audience, kind of like an App Store, oh, I have to, do you want version 2? What is it going to do? That's what OLM does for you. We might have time to talk about that later. It's totally upstream, totally available, operatorhub.io. These run in any Kubernetes cluster. This is kind of like your App Store-like experience. Katacoda. How's Katacoda doing? Is it working? Oh, we're good. Okay.
We apparently had so many connections so quickly to Katacoda that we set off an alarm, and it thought it was under attack. And they were all from the same IP, so it said, oh, hell no, we're not letting these people in. So the threshold has been increased. We should be in good shape. Anybody still having trouble? A little slow? Okay. Hopefully it'll still be workable, and I think we're about to dig into that now.
Yeah.
So we'll find out. Thanks.
Oh, yeah, by the way, there's some bonus materials. I forgot to check the website. It should still be up. Workshop.coreostrain.me. A lot of slides you can download from there. Workshop.coreostrain.me. It's like There's lots of good stuff on there you can download. Lots of resources, lots of access to the support docs and the chat and all that good stuff. Please take a picture real quick. I'm sorry for speeding through all this stuff. I told Michael, I promised Michael, I said, I won't make this one long, and it ended up long, the intro long. I have a hard time condensing. It's a big topic. It's a big topic, okay? Okay, so by the way, if you all are working on an operator, you want to get it certified and featured in OpenShift so everyone sees it. And even if you have an enterprise offering or something that so after people are evaluating the upstream version, come talk to these people in the front here. That's what they do. They help people get their operator certified, going through a series of very strict testing on your image and your operator metadata. Okay, so we're going to go ahead and create an operator with Go. And it's going to be very quick, and I'm going to ask. I'm not trying to be rude, but let's hold the questions. I hate rushing through this type of stuff. It's just, but this is where we're condensed for time. But stick around afterwards. We're going to answer all your questions. Again, we're going to be here to help you. So where we're going is we are going to not the K8's fundamentals, which is a really cool exercise that helps you explore the API, but the Operator SDK with Go pod set. The Operator SDK with Go pod set. And what this is, now look, here's the reality. I notice with these workshops, a lot of people this is the quiet time where it's like, go work on this, but I'm just going to walk through it, okay? Maybe it helps. Okay, so I'm just going to walk through it very quickly. You're free to do this on your own time. Oh yeah, when you leave, you can hit all these exercises not at /training, but just knock off the /training, right? And just go to learn.openshift.com, and you'll have all the modules on there. All the modules will be on there. So when you leave, learn.openshift.com will have all this stuff. So it's not going away. So I guess I have to wait for my environment to come up now. I guess, OK. Let's do this. What we're going to do here is we are going to use the Operator SDK command, OK? And we're going to say here, Operator SDK, new podset-operator --type equals go. Operator-SDK new, and now the gentleman in the back was asking, do you have to use all these things? How does it? So no, here we're saying I want to create an operator with Go. Now you may be wondering, should I go with Go or should I go with Ansible? Which one do I use here? It really depends. It depends on what you're comfortable with. That's all. If you're an Ansible shop and you have tons of Ansible modules that you all have stored in Tower, or you like to fetch them from Galaxy, or however you want to, you use Ansible, you can use Ansible to create an operator. If you all are a Go shop, you love Go, you code in Go, you can use Go. We're going to create a Go one here. But let's see. If this one provision in time, can anyone, I don't know, maybe if we want to, maybe, how's yours? Yeah, because I thought we did this in the beginning. I thought that, oh, OK. Yeah. OK. Oh, here we go. Oh, OK, I'm good, yeah. OK. All right, good. Yeah. OK. All right. So I'm going to create a new project, which for those of you who are like, what's project? What are you talking about? It's a namespace. That's it. OpenShift just uses the word project. That's all it is. So I'm going to click this to create a new project. And then I'm going to create inside my little sandbox in my Go path, right, this Red Hat directory. And then I'm going to navigate to that directory. And then I'm going to create the operator with Go, and I'm going to say skip Git in it, because guess what? We're not pushing this to Git, so we're not going to worry about that. And there it goes. Now, what's happening right now is you're getting all the boilerplate code, and you can probably, those of you who use Go, you know what that screen looks like, right? It's the dep screen that's going out and pulling down all those packages, okay, that are being referenced in that boilerplate code. So getting all that Go code from those import statements that are in the top of the code. This is talking out to the net to do this, so you do need you need external connectivity to run this. And so what's it you're probably thinking, is this creating my operator? How does it even know what kind of operator I want to create? What's happening right now? I'm confused. This gentleman has a question. Yes? Thank you. Thanks. What's the error? Oh, so Oh, okay. 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 Oh yeah. Work. Oh yeah. Oh yeah. By the way, real quick, yeah. Let me just show you this. Somebody asked about this. Where do the? I know. I just want to show you. Workshop. What is it? CoreOS Train. I haven't been to this website in a while. CoreOSTrain.me. Okay. If you want the slides, click on support, and you can download either of these links. This was from the previous KubeCon and Ansible Fest. Yes, we did not update much content here from the previous KubeCon, but we are totally revamping this for the new version of OpenShift. Oh, the URL, workshop.coreostrain.me. I'm going to put it on a big screen here. There we go. Thanks. Thank you. Yeah. So he's talking about the difference between KubeBuilder, which is another way to easily create operators. Now, if you're all familiar with KubeBuilder, so they both Operator SDK and both KubeBuilder both use something called controller runtime, right? Controller runtime is a series of packages, Go packages, that makes creating operators really, really easy. It was developed by the Kubernetes authors, actually, or developers of the API. And there's some news that actually Operator SDK has been working with KubeBuilder directly. So are we going to, do we know anything about the changes with Operator SDK, Michael, and KubeBuilder, like as far as what's working together?
Still pending.
Still pending, but we have weekly meetings with each other. So these aren't two competing platforms, so to speak, right?
Ultimately, the Go features are going to fold under KubeBuilder, and Operator SDK will bring operator-specific things on top of what KubeBuilder currently offers. So that'll be things like packaging for Operator Lifecycle Manager, perhaps testing, and that sort of operator-specific stuff that Operator SDK does today. But that'll all be Go-focused, and probably the Ansible and Helm pieces will stay under the Operator SDK umbrella as it is now.
Yeah, so this isn't really which one should I go with? They're basically going to have the same workflow. Operator SDK is great if you want to be in the Operator Lifecycle Manager and get those kind of features, right? Building out all the artifacts you need for OLM. Yeah. We don't know yet, but okay, well, let's say this. Here's a good question. If I want to get started creating an operator today, what do I pick, though? Right now, tonight, I want to get started with the operator and work throughout the weekend. Which one am I going to pick? What should I do?
I would say, today, like right now, tonight, Operator SDK still has the operator bits that are going to get you all the way to the finish line with Operator Hub, for example, or just generally, if you want to package and distribute your operator even internally, it's got that, essentially, that package management feature built into it and ready to go. So I would do that today.
Cool. Thanks. Yeah. Okay. So, wait, what time are we going till again? Okay. I'm going to go through this pretty quick. So, the first step to creating this Go-based operator is to add an API. What does that mean to add an API? That means to create the custom resource definition, basically telling this code, this is the custom resource definition that I want to use. Make the code aware of that actual object. That's what we're doing here. Okay, so we're saying Operator SDK add API -- API version app.example.com/v1alpha1. So very creative name group here, app.example.com, and then we're going to be creating this thing called a pod set. Now, if you're wondering, what is a pod set? A pod set, in this objective, the kind of operator that we're actually creating, does this right here. It's very simple. It's almost like a replica set, in that like you specify the number of pods that you want, right? And then it gives you that number of pods, and it also has the pod names in the status section. Very, very simple. You may be thinking, well, how is this different than a replica set? It's really not much different at all. Just we're showing you how this is a good place to start to understand creating a controller, okay? Here, if I change the size to 1, the declaration, the pod set should be smart enough to scale down. So you want to have in the spec section replicas and the status section pod names. Okay. So just to give an idea of what we're doing here. All right, so we're going to go and create this add API command. Again, you see what it's creating here? You can see it's creating the CR, the CRD for us automatically. It doesn't know the contents of our custom resource. It doesn't know what we want to have inside the spec yet. We have to tell it that, right? And remember what we want in this case? We want, what was it, replicas? That's what we want inside of our spec, right? We haven't told it that yet. We're going to have to tell it that, okay? So now if you actually look at the CRD has been created for you, all right? Again, I'm skipping over so much. Usually, you know, this is a lot of stuff we're skipping over. Now, we're going into here is, hopefully, if this works for you, you can drill down on the very top to this file location, pod set operator, package, APIs, and I need a refresh.
It seems like the environments are working again for many people. So if you're still staring at that red error message, refresh one more time. Hopefully it'll work.
Okay. So what I'm doing here is, uh-oh. Oh. Let me go, hold on, that's going to make it go fast. There we go. Okay. All right. So what I'm doing here is I am going to create my spec. I have to design my spec, right? What do I want in my spec? I want the number of replicas. So what I'm going to do here is I'm going to drill down into this types.go file, right? Right here, podset types.go. This is where I design my spec. This is where I say these are the fields I want, right? And this is what I want them set to. This is the status that I want. Please open. Okay, there we go. All right. So what we're going to do here is we're going to say, this is very easy with Katacoda. All you have to do is click copy to editor, and it literally updates it just like that. But if you're wondering what this is, spec section, status section. This is a field that can be referenced in Go. It's going to be a 32-bit integer, and then this is a JSON tag. It's basically saying inside the JSON, in that declaration, we're going to have replicas here. And then the status section, we have this array of pod names. That's all we're doing. And after you run that command, after you update that code, you run this generate K8s command. For those of you that are super controller savvy, these are just the code generators that are running in the background here. If you don't know what that is, you never use controllers, don't worry about it. But just understand that's just a little command that we did to run those code generators to create the typed objects based off this information here. And, oh, generate open API. Do you all have, you know what the really cool thing about this is when you all do kubectl edit, like an object, you know when you go in there and you try to change something and you hit return all satisfied that you made your change and it like comes back at you, and it's like you can't do that. That's validation. That's validation taking place, right? You can do that in your spec. So you can say users can't put for replicas, you know, some like long string or something. They can only put a 32-bit integer. You can say they can only put an integer between 1 and 5. You can put all that information into your validation. And that validation goes into the CRD. And now we have our CRD created, and there it is, podsets.app.example.com. Now comes the really cool part where we add the logic controller. The controller is the thing that does the reconciling. Remember that screen that we showed you with the back and forth, the kind of the looping? This is the controller that does that reconciling. And then now what we're going to do is we're going to go and update our logic. Let's see. Let's go into our controller, podset. Podset controller. Okay, there we go. You get some default logic, but it's very, very basic. It just creates one pod. We're going to create this is what our logic looks like. Okay, look, listen, I promise we would typically go through all this and tell you everything that's going on, but we don't have time. We got to talk about Ansible operators. So please come. I want you to scan this. I want you to get your questions ready and come see us afterwards and ask us questions about this, okay? But the most important logic, if you're kind of wondering what's really going on here, the real meat of it, if you will, like the actual thing that we should focus on is if the number available is greater than this is the comparison, right? The number available is the actual state. This is our declaration. If this is greater than this, we're going to go ahead and scale down. If this is less than the declaration, we're going to scale up. That's the most important piece in all this, right? So I'm going to go ahead and apply this. And we should be updated there. You don't have to click save or anything. It should save automatically. And now we're going to run this controller using the up local command. You may be thinking, I don't understand. Why aren't you deploying this with a deployment, like into the cluster? It's because the up local command allows you to compile this code and talk to a Kubernetes cluster if it's externally accessible. So you're literally running a controller outside of the cluster, and it can actually, think about this. The reason why we have this command and we made this command is because, can you imagine if every time you made a little code change, you'd have to literally compile your image, push it up to a container registry, go and put the name into a deployment. Can you imagine how annoying that workflow would be? So this is a really nice workflow to just instantly connect to your cluster and try your code against that cluster, okay? And it's running, okay? How do I know it's running? Well, I have my screen here, and let's go ahead and make sure it works. What I'm going to do here to make sure it works is I'm going to open up a new terminal, and I'm going to go into this directory here, and I'm going to notice that this is set to size. Remember, we set it to replicas? So how do we get this to actually work if it's set to replicas? What we're going to do is we're just going to open up our deploy folder, go to CRDs, go to CR YAML, and click our magical copy to editor button. Isn't this great? Wouldn't this be awesome if coding was actually like this? You just click code. That wouldn't be fun, though. That wouldn't be fun. All right. That wouldn't be very fun. All right. So then we actually go and we say OC create -f deploy CRDs. Let's go ahead and create that. And then we say OC get pods. And the controller, check this out. This is pretty cool. If you look at the terminal, notice how instantly when I created that custom resource, my controller got an event. You can look at all the logs here. And then it scaled up based off that event, et cetera, et cetera. You might be thinking, I don't understand. This is such a simple example. Why are you showing us this? It's like a replica set. What's the big deal? It's academic. We're just study this, and this will prime you for understanding how the controller loop works. Play with this. Play with this. Play around with it. Modify it. Break it. Get comfortable with how this controller is actually working. We can actually see that if we actually go in and we say OC get pod set, this is pretty cool. Just like this, OC get pod set. -o YAML. You see that? How the pod names got put in there? Okay? It's pretty cool. You look at the code, you'll see the relationship there. Again, we go through more, but we have to move on to the Ansible operators, right? Let's go ahead and do that. Yeah, Michael, do you want to talk about that? Yeah, real quick. So the gentleman asked about garbage collection. Where is it? How does it work? Where can I see it? You can see it in the code, but if you want to see it in person, you just say OC get pods. Let's look at a pod and see if it has a garbage collection owner reference on it. I'm going to grab the first one here. I'm going to say -o YAML. Let's grep for the word owner ref, and let's just go down. Maybe that. See it? It's in the metadata section. There it is. So these pods have owner references on them, right? And what does that mean? It means that if I actually go and say OC delete pod set, example pod set, guess what? Terminating, okay?
All right, how's this looking? Fantastic. We're plugged in, we're ready to rock. Let's look at the easy way to do this with Ansible. Now I'm going to apologize up front. I've got a bit of a cough. I'm going to try my best to not cough into this microphone, but we'll see how it goes. So why would you do this with Ansible? So the Ansible side of the Operator SDK makes it particularly easy, orders of magnitude easier, to deploy and manage applications with operators, as opposed to doing one from scratch with even with the Go side of the Operator SDK. And let's look at how it fits naturally. So Kubernetes and Ansible, very much playing in the same kind of mindset. They're both all about automation and orchestration. Open source, very popular, active communities on both sides. But two things that I like to focus on are they're both YAML-based, and they're heavily YAML top to bottom. So you're already familiar with that. They're both also all about declaring your desired state. So in the Ansible side, if you're not familiar with Ansible, you create an Ansible role such that you can run it over and over and over again. And no matter what the starting state of your infrastructure was, it will end up at your desired state. Very much like a controller in Kubernetes already does anyway. So these are a really natural and a really good fit for each other. So let's look at using Ansible as a client to interact with Kubernetes. So on the left, we have normal YAML, like you might see in a file. You could kubectl create-f, this config map, and you'd have a config map. On the right side, this is actual Ansible code, and you can see I've just inlined. I've directly inlined the exact same YAML, and this will, using the K8s module, directly create that resource, or it'll ensure that it exists in the desired state. So it's a little bit like the apply verb that you're probably used to. Now, the one difference here you may see is I've taken the liberty of just showing off a little bit and templatizing that last line. So we've templatized color. And when your Ansible code runs this way inside your Ansible operator, any key value pairs you put in your spec on your CRD get plumbed in here at render time for Ansible to use. So if you have color red in your spec of your CR that you just created in your cluster, then when Ansible runs, it's going to use that, and it's going to render this template using those values, and it will ensure that this resource has the value red, as the string red there as the color. So pretty neat. Now, what if you don't want to inline your YAML? I don't really want to inline my YAML either. There's a better way. You can maintain your YAML manifests as separate templates and templatize them just the same way, but keep them in a separate directory inside your role. And with these 3 lines, we're using the lookup feature of Ansible, which is a staple core feature of Ansible that's used in many different ways. We're looking up the template that has a certain name, and we're just rendering that. And the K8s module understands how to receive that as its input, and now it's just going to basically apply whatever has been rendered out of those templates. So this is a very natural way to interact with Kubernetes from inside of Ansible. So why build operators with Ansible? Cutting right to the chase with these things, ultimately, it's about the ease, and the ease of getting started, the ease of maintaining. You can have an operator with no previous experience at all, even if no experience with Ansible even itself, up and running in under a day. When your boss comes to you and says, hey, we bought OpenShift, congratulations, and now you have to go make operators for these 12 things, and I need them by the end of the week so we can continue to deploy them, you can get that done actually in a big hurry. And you can take even whatever YAML manifests you've already been using to deploy your workloads, maybe with other tooling, maybe not, and feed them in here and create an operator very quickly. But you still have the full power of Ansible, so you can do anything. Fully advanced day 2 management of your workloads is still totally within realm. That's all I'll say about that for now. We looked at this already earlier, so you're familiar. Now, how does a controller work? Matt already talked through this. We're going to compare, this is a normal controller, and we're going to compare this in a moment with an Ansible-based controller. So in this normal one, we've got this controller in the middle. It's watching events, right? Anytime a custom resource or a resource of any kind changes that it is watching, it gets that event and it runs that reconcile function, right? Now what happens when we drop Ansible into this? Here's what we have. Inside that controller, we have created for you a generic binary. It's written in Go using the Operator SDK, and it runs and it'll watch whatever resources you tell it to watch. So we have this watch file that we'll look at in a moment that really just says, for this group, version, and kind, when you see an event for that group, version, kind, run this Ansible playbook or run this Ansible role. You can do either one. So it really ends up being very simple. There's some other advanced features around this, but then the Ansible can run and do anything it wants. Now, Matt was talking about owner references earlier. Now here, this automatically puts owner references on every resource you create for you. So it knows what your primary resource is, and when you create secondary resources, it will do two things. It'll put the owner reference on it, and it will also start watching that other resource type also, and it'll use that handler, if you're familiar with the Go side. It will enqueue the parent resource when it sees changes in the child. So a lot of stuff happens very naturally for you here. Finalizers are super easy, and so on. So, automating with Ansible, doing this for the first time, what are you going to do? You are going to create a role or a playbook that understands how to deploy an application. So if we were going to deploy MariaDB, we would create a MariaDB role and fill it out so that it understands how to deploy MariaDB on Kubernetes. In this context, in the operator context, the custom resource input is going to be passed into Ansible at runtime. So when we run Ansible, all that input gets passed in and is used by Ansible to render templates, for logic, branching. You can do effectively like if kind of statements in Ansible. You can run a block of code only when an expression is true. So all those things, you can use that input to, in very powerful ways, make decisions in your Ansible code. And so typically you're going to use the K8s module. There's a collection of other related Kubernetes modules around that to do things like manage the status and other things. And then if you're interacting with any external services, you can use that as well. We've seen somebody creating an operator with Ansible to manage a physical switch that's on the top of their rack of hosts that turn into nodes in their cluster. So they're managing their Kubernetes infrastructure from Kubernetes, including the switch. And they're using Ansible's very rich collection of network equipment roles to do that. So let's keep moving. This is what that watches file looks like. Like I said, really nothing fancy here, just group version kind mapping to a playbook. And this gets scaffolded out for you by the Operator SDK, as you'll see. Now, with your custom resource, in the spec, so let's say we're making this MariaDB operator. We've got a MariaDB custom resource definition. When I create one of those resources, in the spec I can put any key value pairs I want, and those get passed into Ansible. Now, what about the status? You have two options. The easy option is we take care of it for you. The Ansible-based operator will create a default status. It's fairly generic. It's not going to be specific to your workload, but it is a useful and informative status that says things about what happened when Ansible ran. Did it encounter any errors? Did it change anything or not? Those sorts of things. And then probably is the last thing we'll look at before we dive into the exercise. This is what the image really looks like for your Ansible-based operator. All the stuff on the bottom is provided for you. That binary, Ansible itself is in the image, all the libraries and dependencies you need. All you add on top are that watches file and whatever roles or playbooks get referenced by that watches file. So it's really very simple. In terms of artifacts, it's very little for you to manage. So you can already see this is a very different picture than managing an entire Go-based software project yourself. I'm a software engineer. I love writing in Go. I would be happy to write Go all day long, but not every organization wants to throw a full development team onto every operator that they need to make. This is a very different way to manage the artifacts that you need. Organizations generally are very used to having small teams, ops teams, teams that are not even software engineering oriented, owning and maintaining Ansible assets as a regular matter of course. And that's just as easy to do here with your operator. Okay, let's go back to our exercises. And let's see, mine is alive and well. Now, I've got good news for you about this exercise. It's a 9-step exercise. The first 4 is just reading. And I already told you all that stuff. So we're just going to fast right forward past that all the way to step 5. And about halfway down, sounds like they're already tearing down the conference over there. Hopefully that's not an earthquake. I'm an East Coaster, so I'm not used to that fear. Okay, Operator SDK new, just as you might expect, right? So we're going to run Operator SDK new. We're saying type is Ansible. We're giving it the group version and kind right up front. And it just scaffolded out an entire operator for us. Let's look at what we got with this tree command, right? What do we have here? Okay. So we have a build directory and we have a Docker file. We could build this operator right now. We have a working operator already. The bad news is it doesn't do anything, but it will totally watch our resource. It will run the Ansible role that it just created every time that resource has an event. There's just nothing in that role yet. But we already have everything we need. We could run Operator SDK build right now, and this thing would run. Deployment, this is all the usual stuff you get with the SDK, whether it's Go or Ansible or anything else. So we have the CRD, we have an example CR, and so on. All the stuff you need to deploy your operator into a cluster. Molecule. Anybody familiar with Ansible's Molecule project? Yeah, big fans in the Ansible community of Molecule. It's a whole testing framework. It's super useful, as it turns out, for operator testing. Not even just Ansible operator testing, by the way. Even if you're making operators with something that's not Ansible, like in Go or otherwise, excuse me. Molecule, it turns out, is a really useful way to stand up a transient cluster very quickly, throw your operator into it, test it, and tear the whole thing down and give you very quick feedback cycles as you're developing your operator. So that's really cool stuff. Wish we had more time to go into that right now. Okay, roles. Ansible roles. So we got a memcached role scaffolded out for us already. And in all this stuff, there's really only 2 things you need to worry about inside here. One is tasks main.yaml. That's where we go. That's like the main function in your program. That's the starting point for our Ansible code. So that's where we're gonna start putting Ansible code. And then the templates directory, that's the directory where we can put template files. So any YAML manifest you already have, you can just stuff them in there and reference them from that main.yaml, like we saw a few minutes ago on the slides. And then last but not least, we have this watches.yaml file, as promised. That's the file where we look and express for the group version kind, run this role. Because the Operator SDK already knows what group version kind you're going to use. It already created the role for you. It has already filled out the values in that file, so we don't even need to touch it. It's already ready to go. So let's press on. So our next step is to customize the operator logic, because right now there is no logic. Now, rather than sit here and type out some Ansible code, we're going to take the easy path. We're going to take the lazy path. Thankfully, one of my colleagues, Dylan Murray, created a role for us. It's going to deploy memcached. So what we're going to do here is use the Ansible Galaxy tool to download and install that module for us. And Ansible Galaxy, the command, there's really nothing fancy going on here. It's just retrieving that off of GitHub for us and putting that role here in our roles directory. So if we type one-handed and look. Okay, so in the roles directory, look, we've got wait, I missed a step, didn't I? I missed a CD into my memcached operator directory. Don't make that mistake like I did. And I'm glad I caught it just then. So let's run this again. And let's ls in roles. That looks better. Okay. Now, we have that old role, that original one that got scaffolded out for us. We're just going to delete that. We don't need that anymore. And let's take a closer look at that. If we look into that role, it looks very similar. Dylan's customized it a little bit, but again, let's see, it's got that tasks file. He doesn't actually have templates. He's not using templates here. He inlined all the YAML. You can look at it yourself if you like. But we just have that main.yaml file, and that's really the only thing you need to worry about to get an awful lot of stuff done. We can go and look at the defaults. Let's see. Oh, this is not. Sometimes this text editor lags. Ah, here we go. Memcached operator, roles, Dylan Murray, defaults, main.yaml. So in the defaults, we can set defaults for different things. In this case, we've got a default of size 1. We'll just stick with that. And you can see here, this is a printout of what Dylan did. And you can see that we're using just Jinja-style templating here. And he's referencing, so meta.name, that is the name of the custom resource that you just created. So if I had a memcached resource in a YAML file, and I kubectl create-f that thing, this operator is going to wake up, it's going to see that event, it's going to run this code, and it's going to use the name of that, that CR to create the name of this deployment. And you did the same thing in the namespace. So that's pretty cool. And finally, the size. We're using the size also in this template. Again, as Matt was saying, this is not a brilliant operator. In fact, this is kind of a silly operator. Why would you do this? We're just re-implementing sort of what a deployment already can do. But this is the pattern. It's academic. And you can see how you could add logic onto this to do more advanced things like upgrade logic. Fixing things when they're broken. Any kind of custom logic that has to happen when you scale up and down. Some things like etcd, you can't just start up new etcd processes and expect that to work. There's a whole workflow of introducing new nodes into an etcd cluster, for example. Many other databases have the same kind of thing. So you can imagine how you would add that extra kind of logic to your Ansible role. Okay, we do need to correct our watches file because that role is in a different file path now. We just need to change the path on disk to that role. And by the way, what this is, that's the path on disk inside the container image for your operator. When you build your operator's image, you've got a Docker file for your operator. You're going to put your role somewhere, and it's got to be wherever this thinks it is. So you just got to make that match. All right, let's press forward. It's time to deploy this thing. All right, OC. Did we cover what OC is? Great. OC is just like kubectl. Okay, we created our CRD. Great. So we've extended the Kubernetes API. What a miracle that is, by the way. How many systems do you know that let you just extend their API with your own things? It really and it enables so much. It's a great feature. Okay, we are building our operator. We're in the extracting phase. Okay, we have built the operator. Now, we needed to just hand wave a little bit. We're going to tell, you have to choose a name for your operator image, right? Your container image. The SDK doesn't know, it can't read your mind and know, is this going to be on Docker Hub? Is it going to be on Quay? Is it going to be in your own registry? Is it going to be somewhere else? So you have to pick when you build, when you run that build command, where you're going to host, like what's the full reference to your image going to be. So we just need to put that here in our deploy manifest for the operator. That's all we're doing here. And we'll change the poll policy just to help with the demo. All right, New project, we know what new project does. We did that in the last exercise. That creates basically a namespace for us with some other features around it. Service account, role binding, all very critical things for your operator. By the way, notice that Operator SDK scaffolded those things out for you, and they're already ready to go with defaults that get you started. We don't have to muck around in there yet with the RBAC. Okay, it's time to actually deploy the darn thing and cross our fingers and hope that our operator starts successfully. And it looks like it did. Okay, congratulations. We just made an operator. Thank you. Thank you very much. Okay, pressing forward. Let's actually use the darn thing and just see it in action. So we have a custom resource here. It's the kind is memcached, like we were looking at earlier. Just this is the Ansible implementation of that. We can go look at that file. Let's see, is it this one? Yes, it is. Okay, so by default, we have a size of 3 here. And this is our memcached resource. Let's, I don't know, let's just change it to 2, because why not? And let's create that CR and see what happens. Okay. Now, hopefully, just now, we created that CR. Our Ansible operator is running. So that Go binary that we created for you, it was already watching memcached resources. It saw the event. It noticed the group version kind of the resource that the event was associated with. It looked in that watches file, that mapping file, and said, okay, I know what role to run, and it ran that role, and it injected the entire CR, all the contents of the CR as input when it ran Ansible with that role. And when that role ran, and as we saw in that role, it should have deployed, or should have created a deployment. And it did. We have our example memcached. We have to find a better name for that. Deployment running. There are desired 2 pods. There are currently 2 pods. They're available. Life is beautiful. This thing works. Love it when a plan comes together. Okay, we can come here. We can change the size. I don't know, say 5. We can OC apply. We can give it a moment. There we are. We've got 5. Only 2 are available, but there's 5 pods. Okay, now they're all available. So it's that easy. We've taken Ansible. We've taken very simple Ansible code. We've made it Kubernetes native, as they say. And a big part of being Kubernetes native is plugging into the Kubernetes API. So there is now a custom API in this cluster representing memcached, and plugged into that, we're plumbing all the way from that API. We're calling into Ansible, and we've exposed this Ansible code through that. Yes, sir? We could. I'm trying to type one-handed, so I'm not gonna. But yes, we could, and I would encourage you to run this exercise when you get home and give that a try. But it absolutely would. If any outside actor comes and changes this deployment, that's going to generate an event, and it'll notice that event. I mean, that is literally actually what we just did, I guess, on the CR. But just like it's watching the CR, it's also watching the deployment. That would kick off an event and fix whatever somebody had screwed around with. Okay, we've got the memcached resource. Let's just look at the status real quick. So like I said, it's a generic status, but it shows that the last time this ran, nothing changed. 2 things were okay. These are Ansible tasks. And by the way, Ansible code typically is a series of tasks. In traditional Ansible, it's often, a role to like deploy a service on like a physical Linux machine or something. So you might start by, ensure these RPMs or Debian packages are present. Ensure that these ports are open on the firewall. Ensure that some config file exists in the right place. Create a systemd unit file. Enable that systemd unit file. All those kind of things. Each one of those is a task going down your YAML file. And here we're doing the exact same thing with Ansible code. We had 2 of those tasks apparently in here, and they both ran. Neither of them changed anything. Neither of them failed. So overall, pretty boring run there of Ansible. OK, now what if... all right, I'm going to put the mic down for 10 seconds. Be right back. Is it on? There we are. Oh, great. OK, thank you. Thanks. OK, OC get deployments. We're back. I think it already fixed it. So I scaled it down to 2. We can look at the pods and probably see that some are much newer. Yeah, see, these are only 3 of them are only 15 seconds old. So there you go. Scaled down, and the thing went right back up and did it. So if your intern gets in there and starts messing with stuff they shouldn't mess with, your Ansible-based operator has your back. And just like that, we can also delete this thing. Get the pods. So we deleted the CR, and it's oh, did I? Oops, I deleted the I deleted the operator instead. Oh well. I think we've made the point. The next part of this exercise we're not going to go through right now, but you can go through on your own, is a way to run your operator locally. When you're developing and iterating on your operator, whether it's Go or Ansible, it slows you down if you've got to build a new image and push the image to a registry and then wait for your cluster to pull that image and deploy that in a pod. So the Operator SDK has a run local command or up local command that you can use to run the operator like locally on your laptop, and you can get very, very quick feedback cycles that way. And so the rest of this exercise just goes through that. Now, when you get home this weekend, if you're just so excited about this whole week, you just got to make yourself an operator. You can do that. Just go to learn.openshift.com without the training part on the URL. And all these exercises are there. There's not enough capacity there for 400 of your best friends to do it with you, so that's not why we didn't use it today. But you can individually do that anytime you want. There's no sign up. There's no information collected. It's just totally free and open. Anybody can do it. Thank you. Yep. Lots of other operator exercises on there, so go learn. We're going to stick around. I think they might kick us out of here, so we might just move right out there. But come ask us all your questions. We're here for you. Thank you for coming.